Okay, on the upper left of your screen, you're asked to solve the system of equations y equals 5x minus 4 and 2x minus y equals 7. Now, if we graph these two lines, they will cross at some point. To be honest with you, I can't discern what that point would be, but I know that it would be someplace over there in yellow. To solve a system means find a point that is on the first line and the second line simultaneously. In other words, that one point of intersection must be on both lines to be the solution to a system of equations. Well, in this case, it's very hard to discern graphically, so let me show you a way to solve the system algebraically. Since with the first equation you have y by itself, what we're going to use is the method of substitution. So we're going to use substitution. And let me rewrite the problem. So you're going to take y equals 5x minus 4. I'm going to put that in parentheses, and I'm going to plug it in or substitute in this value, 5x minus 4, for the y value in the second equation. So we wind up with 2x minus. Now, why did I use parentheses? Because when you're substituting a binomial, you must use parentheses. Okay, so now we have, after substitution, we have one equation, one unknown. And then if you do have one equation with one unknown, you should be able to solve for the x value of this intersection point. So this is going to be some x and some y that we're solving for. And we'll plug in the actual answer as soon as we solve for x first. All right, next step. How do you solve for x? Remember to distribute. And you wind up with 2x minus 5x plus 4 equals 7. Next step, collect like terms. Negative 3x plus 4 equals 7. Next step, subtract 4 from both sides of the equation, and you get negative 3x equals 3. Divide by negative 3 on both sides, and you wind up with x equals negative 1. So that tells me that the x value here is negative 1. All right, so have we solved the system? Well, the answer is no, because to solve a system means you need to find the point of, in this case, the point of intersection. That means we need to now go back and find the y value. And the way we do that is you can go back to any of the two equations that we started with. The easiest one is to use y equals 5x minus 4 because y is already set up. So this becomes now y equals 5 times negative 1 minus 4, and the answer would be, yes, the answer would be, let's see, this is negative 4, so the answer would be negative 9. So I'm going to now put in the point negative 9, and that is your point of intersection. So the solution to this system of equations, you can either write it as x equals negative 1 and y equals negative 9, or you can write it as a point, and in this case, it's the point of intersection. Okay, let's try another example. Equals 30. All right, well, in this case, I'm going to rewrite the two problems. So x equals, I'm going to put the x value, which is now 3 minus 4y in parentheses, and I'm going to substitute it into the second equation. So here we go. So 2 parentheses minus y equals 30. I'm going to take this value and plug it into here, and you wind up with 3 minus 4y. Again, our goal is to have one equation with one unknown. In this case, we are solving for y first instead of the x first. So we wind up with, now after distribution, we 6 minus 8y minus y equals 30. Collect like terms, so it's 6 minus 9y equals 30. I'm going to subtract 6 from both sides, to isolate the y term, and you wind up with minus 9y equals 24. Divide by negative 9 on both sides, and if we reduce the fraction, which is going to turn out to be negative, well, 3 goes into the numerator 8 times, and 3 goes into the denominator 3 times. So that means my y value is a fraction, which is possible. It just means that it will be somewhere either in the point of intersection will be somewhere, well, it'd either be quadrant 3 or quadrant 4. So at this point, again, it's difficult to graph. That's why we have an algebraic way of solving. So now let's solve for x. So x was equal to 3 minus 4y. 3 minus 4, well, what is y? Y is now negative 8/3. So x equals, let me clean up this. So this is 3 plus 4 times 8 is 32 over 3. Well, we need to find an LCD for this one, so I'm going to put a 1 under here. I'm going to multiply this by 3 and this by 3, which is 3 over 3 is a quantity of 1. We are rewriting the number 3 as 9 over 3 plus 32 over 3 equals, what is this, 41 over 3. Now, not a pretty solution, but it is correct. Now, actually, I'm not sure. Why? Because I haven't checked yet. So let's just write the solution, and then we must check. It's always a good idea. Well, so the x value was 41 over 3, and the y value was negative 8/3. All right, now the most important part is the check. I'll admit this is not going to be fun to substitute in, but it is doable, and I just want to show you how one would do that. Okay, so x now becomes 41 over 3, and this becomes 3 minus 4 times negative 8/3. All right, on the right side, let me do it right away. So this becomes 2 times x is 41 over 3 minus y, which is negative 8/3. Does this equal 30? I'm going to put a big question mark, because if we made a mistake, that means we have to go back and check our work. So, all right. So 41 over 3, does this equal, well, 3 over 1 minus, or positive 32 over 3. Again, we're going to multiply both sides by 3. Does 41 over 3 equal, that's 9 plus 32, that's 41 over 3. So far, so good. It just simply means that this point is on the first line. Now, for the check to work, that point has to be on both lines. That's what solving a system means. So if it's on one line and not the other, a mistake was made, go back and redo. Okay, let's try this one. 2 times 41 is 82 over 3. Plus 8 over 3. Does this equal 30? I don't know. Let's find out. 82 plus 8 is 90 over 3. Does that equal 30? And the answer is yes, 30 equals 30. All right, now I can say with confidence that the solution to this problem is right here. I just want to go back to problem 1 and do the check in red. And by plugging in the y equals 5x minus 4, I plugged in the value y is equal to negative 9 and x is negative 1, and indeed it checks. And for the right equation, it's 2 times negative 1, subtracting a negative 9, and you do wind up with a true equation. So indeed the answer is negative 1, negative 9. So it's always important to check, because if you make one little sign error, it'll throw you off. Okay, please try to solve the following system of equations. Please pause the video, try it on your own, come back and look at the solution. Okay, let's take a look at the solution. So we have y equals 4x minus 3, 2x plus 2y equals 14. We're going to use substitution method, and wherever we see a y, we're going to plug in this value into here, distribute, and you get 2x plus 8x minus 6 equals 14. Add 6 to both sides. 10x equals 20. X equals 2. If x equals 2, I'm going to plug in 2 into this value right here. And I think at this point we can say the answer is 2, 5, but I think it's a good idea to check. So how do you check? Go back to the original two equations, make sure it checks for both. So the first was y equals 4x minus 3, and the other equation was 2x plus 2y equals 14. So let's see what we get. Okay, let's take a look at the next two examples. Example on the left here and the example on the right. By substitution, you're going to plug in y equals, the value for y is 2x plus 3. I plugged it into here, and I wound up with, unfortunately, a false statement. When you wind up with a false statement, it means that there is no x and y value that will satisfy both equations. And we say that there is a no solution. If you graph this, you will see that these two lines are parallel. And if you recall, parallel lines have no points in common, which means that there is no point of intersection that is common to both. Okay, in the example on the right, after substitution, you wind up with a true statement. Well, this means that these two lines are actually congruent, which means if you graph them, you'll see that one will be right on top of the other. They're congruent. They're exactly the same line. In fact, if you go back to the original here and you divide by 2, you're going to wind up with x plus 2y equals 3. It's the same exact equation. Therefore, when you graph them, they're exactly on top of each other. When you get a true statement as such here, and the x's or the y's drop out, we say that the answer is infinitely many solutions. And those are the two exceptions. So again, if you wind up with a point of intersection, that means these two lines cross. In the example on the left on the screen, if you wind up with a false statement, there's no solution. The two lines are considered parallel. If on the right you wind up with a true statement, it means that these two lines are congruent, which means they're exactly the same line, and every point matches, or we say there's infinitely many solutions.